All right, Layne, who is ready to learn? It's you. I know you're ready. All right. So quickly, we went over the subtraction and absolute value of the difference, and I recorded it all without any sound because I didn't turn on the microphone. So I'm going to do like a quick recap. And basically, it comes down to this. To subtract integers, we change the sign of the integer being subtracted and then add them together according to their rules for addition of integers, i.e. for integers a and b. So instead of writing a minus b, we do a plus negative b. So all of these, that is exactly what we're doing. So if you are subtracting a negative, you can see down here that 3 minus negative 10, we turn both of those into plus signs. And we just continued on with that. And you just want to be careful with absolute value. Remember the absolute value, find that, and then do the plus a negative. All right. Same with this. This is a very quick, the absolute value of a minus b equals the absolute value of b minus a, because all you're doing is finding the difference between those numbers. Whether it's positive or negative, it's going to have the same absolute value. All right, so we are headed on to today's lesson, multiplication and division and combined operations of integers, my dear and my sir. All right. The multiplication. Micah, stop focusing on the cat, please. All right. The multiplication of integers can be regarded as repeated addition. For example, if the integers, for the integers 2 and 3, we have 2 times 3. So that's 2 plus 2 plus 2, which equals 6. We could see that right there. Extending this idea to the product of negative number and a positive number, we do that. So negative 2 times 3 is negative 2 plus negative 2 plus negative 2. So it's negative 6. Now, if we do that and we switch, we do positive 2 times negative 3, we end up with negative 3 plus negative 3, so it's negative 6. So basically, if either one of those integers is negative, your answer is going to be negative. And you can see this played out in this number line if you need to. All right. Righty-roo. Righty-roo, I love you. All right. Clash activity. Let's see if we can get any good stuff from here. By considering the given number patterns, copy and complete the multiplication table. All right. So 0 times 3. We know that this 0 thing, that's a waste of our time. That's just all going to be zeros. And same as this. So we're not doing those. All right. So if we have negative 1 times 2, it's negative 2. Negative 2 times 3. It's going to be, negative 2 times negative 2 is negative 4. Negative 3 times 1 is negative 3 times 2. It's negative 6. Negative 1 times negative 1 is negative 1. Negative 1 times 1 is negative 1. Negative 2 times 1 is negative 2. Negative 3 times 1 is negative 3. All right, so then we get this negative 3, -2, -1, -6, -9, -4, -6, -2, -3. This is where it gets fun in this box right here. So if we have a negative times a negative, then we end up with a positive. -1 times -1 is 1. -1 times -2 is 2. -3 times -1 is -3, is 3. So all of these are going to be positive. So if we think through this, if it's capable for me, if I am capable of thinking through.
Positive is positive, negative is positive, negative is negative, and negative positive is negative.
Yes.
So when it's crossed, when you multiply them by, if you multiply by positive and a negative, it's going to be negative.
Yeah.
But if you multiply by each other, it's always going to be positive.
So if you have negative times positive, we're always going to get a negative. If we have negative times negative, we're going to get a positive. If we have positive times positive, we get positive. And if we do positive times negative, which is the same as that, obviously, we would get negative. Now, Layne, that may not mean anything to you right now, and that's okay. We're going to flesh this out. Or you may be like, Auntie Callie, I get it. I get it. So, woo, that was exciting. So if we do one of these just with a number line, right? So Micah, if I write this number line, I can't do multiplication on a number line. Just kidding. All right, let us recall the rules of arithmetic for whole numbers. So we have A times B plus AC. Yes. Yes. Okay. Those are two separate things. Regardless of which way you multiply something, you're going to get the same answer. We want these rules to continue to hold when negative numbers are used. So suppose C equals 0. Okay. We will have A
plus 0.
Hang on. A times B plus 0. So that would be A times B, right? Because we do these two together. Then we do plus A times 0. So then we end up with AB equals AB plus A times 0. So B plus 0 is B. So AB plus 0 is AB equals 0. AB equals AB. That's fun. Subtracting AB from both sides of the above equation gives AB minus AB equals AB plus A times 0 equals AB. Therefore, A times 0 equals 0. So, all that to say, we have learned that for any number n and negative, for any number n and negative n are opposites or additive inverses, such that n plus negative n equals what, Micah?
N plus negative n equals 0.
Yes. Layne, this again, let's flesh it out before you freak out, okay?
flesh it out, and then we freak out.
Flesh it out, and then we'll freak out. So, thus, we can write a times 0 equals 0 as a times b plus negative b equals 0. AB plus a times b, because they distributed the a, equals 0. Subtracting AB from both sides of the above equation gives A times negative B equals negative A times B. For A being greater than 0, we can do negative A times B plus negative B, because this would be 0. So that would be negative A times 0 is 0. Negative A times B plus negative A times negative B equals 0.
B times negative A.
Because this is going to be a positive and this is going to be a negative of the same thing. So then it would cancel each other out. This is going to be a positive AB. This will be a negative AB. We add it together, it cancels out. Yes. What? No. No talking?
Nothing.
Nothing. Okay. Yeah, that's okay. All right. Adding BA to both sides gives this. So we have negative BA plus A times B plus BA. So we know these are going to equal 0 plus BA. So negative A times negative B equals positive B times A. So therefore, all of this gobbledygook, Layne, if you're not tracking there, it's okay. It's not the end of the world. All of this gobbledygook, it just comes down to this. This is the big thing. When we are multiplying two negative numbers, the answer is going to be positive. That's it. So, yes, at the very beginning. But that is their proof work. So some people, like your older sister, she would need all of those steps because she wants to see why. All right, so from the results of the class activity, we see that A times B equals a positive A times B. We see negative A times negative B equals a positive A times B. We see A times negative B equals negative A times B. And we see negative A times B equals negative A times B. If two numbers have the same sign, their product is positive. If two numbers have opposite signs, their product is negative. So that's a more concise way of saying, instead of saying positive plus negative equals negative, it's if they have the same sign, it is going to be positive. All right, so let's do some of the things, okay? Because it sounds a lot more complicated than we need it to be for right now. So negative 6 times 9 is going to be the same as 6 times 9 put to negative, right? So that would be negative 54. And here's that proof equation next to it. Then we have negative 4 times negative 4. Now from our meat and potato box, the previous page, we see that numbers that have the same sign are going to be positive. And this is a case where the numbers have the same sign. So the answer is going to be positive. Now in this one, we can see, now this is where it gets tricky. We have 3 integers here. 3, Micah. We didn't go over 3.
Would you do -4 times -7 and then multiply that by negative?
Well,
By 8.
so PEMDAS has us do multiplication first, right? Both of these are all multiplication. However, we start from left to right. So we are actually going to be multiplying these two first, and we can see that demonstrated on this side, and then multiplying by a negative. So then we end up 8 times 4, 32, and it's a negative, times -7. So we end up with positive, right? Because 2 of the same signs equals positive. 32 times 7, and the answer is 244. So recall that 4 times 4 equals 16. And we say that 4 is the positive square root of 16, and write the square root of 16 is 4. As -4 and -4 equals 16, we say that -4 is the negative square root. So Micah, look at this. So if we wanted to know what is the negative square root of 16, well, it's negative. In general, each positive number x has 2 square roots, which are the positive square root and the negative square root. Do you understand that?
Yeah.
Okay. So Layne, if we have -4 times -4, we get 16. Therefore, the square root of 16, and we have 4 times 4 equals 16. So therefore, we can say the negative square root of 16 equals -4, and then we can say just the square root of 16 equals 4. Now I think that's a little tidbit that we're probably going to handle more later. So 8 times -12. That answer, I'm not going to go over the answer for it. I just want you to tell me positive or negative. Negative. Now, -3 times -6. What is it going to be, Micah?
Positive.
Why?
Because it is a negative times a negative, and if you have the two of the same type, whether it's negative or positive, you will be getting positive.
Bingo. Now, this one. Tell me what it is, but walk me through it. Left to right.
Okay, so, like one of the problems before, we have negative times a positive times a negative. So we do the negative times a positive, but we have the negative on the outside. So it's like 5 times 6 in parentheses and then negative on the outside times -4. So it would be 5 times 6, -5 times 6 times -4.
Yeah, so when we multiply a negative and a positive, when the signs are mixed, we end up with a negative number. And then we're going to multiply that by the existing negative number, and we get a positive number.
Wait, let me figure it out. $120.
All right, so moving right along, let's look at the division of integers. Okay, so you're going to find it looks a lot the same. 4 times 3 equals 12. 4 times -3 equals -12. Let's look over yonder here. 12 divided by 3 is 4. So look at this. We have 4 times -3 equals -12. So if we take -12 divided by -3, we get 4. So this is the same deal. What is it telling us?
Two types of the same two of the same type.
Sign.
Two of the same sign equal positive. But yeah.
Yep. So we observe that division is the reverse process of multiplication. Hence, the rules for division of integers can be derived from the rules for multiplication of integers. So it's going to be the same jam. It's going to be I took a picture of that page twice. I was looking for a meat and potatoes box and it wasn't there. But there it is. So this is for any positive integers, A and B. And it goes back to the same principle right here. Okay? If two numbers have the same sign, their quotient is positive. If two numbers have a different sign, their quotient is negative. So recall that A over B equals C when A equals B times C. If B equals 0, then 0 times C equals 0. Hence, A is not 0. A over 0 cannot be found. If A equals 0, then 0 equals 0 times C for any C. Hence, there could not be and many possible values for 0 over 0. For this reasons, we say that A divided by 0 is undefined. Okay, so don't mess with the zeros.
Infinity. Dad said it's infinity.
Uncle John said it's infinity.
Because
So we can...
if you have one piece, it's like you have one object. But if you have 0 pieces, it expands infinitely. You need to have like a bajillion things.
That's beyond where my mind can process. So I'm going to say that's like a YouTube video search of why A divided by 0 is undefined or infinite. Because that makes my head spin in ways that I'm just not interested in spinning today.
So did I, because if you don't have a pizza, it's cut into 0 pieces.
Then what is happening?
What is the
Okay,
pizza?
that's...
What is the pizza?
It's like a Schrodinger's cat.
What's a Schrodinger's cat?
Anyway, we'll look it up. Hang on. Just.
Mm.
All right. So find the values of 42 divided by 7.
42.
What's 42 divided by 7, Micah?
42 divided by 7.
It's 6.
Yes.
So because we have a negative and a negative, we have matching signs. We know our answer is going to be positive. Look here, Layne. We've got a negative and a positive. If we have mismatched signs, our answer is going to be what, Micah?
Negative.
So 36 divided by 3, or negative 36 divided by 3 is negative 12. All right, Micah, give me the answers for A and B.
A, 54 divided by negative 6 is negative 9.
Negative 9.
And negative 75 divided by negative 5 would be 15.
Bingo. All right. Let's just keep on keeping on, okay? Layne, this is just a long video. If you need to stop in between, do it. It's whatevs. We should observe the order of operations on integers as follows. Evaluate the expressions within the innermost pair of parentheses first, if there is more than one pair of parentheses. So, if I had 3 plus 2 times 4 times 7, I am going to do the innermost pair of parentheses first. Okay, because math can get kind of crazy. Evaluate the exponents. Multiply and divide from left to right. Add and subtract from left to right. So, combined operations. So this is like PEMDAS, but now you guys can view PEMDAS in a different way.
But when you add it, doesn't really matter. Because you're going to get the same answer.
Yeah. But this is something that we've never combined exponents and negative numbers into this, and a whole bunch of parentheses into this PEMDAS business, okay? So let's look at these problems. Let's put our PEMDAS mind, and then get to it. Can you not swing that, please? Put it down. I believe in you, Micah. Pull it together. All right, negative 16 times negative 9 divided by 6. So this is multiplication, division. We're just going to be going from left to right. So we have here negative 16 times negative 9. And we know 2 like signs means the answer is going to be positive there. So that's why they just have 16 times 9. And then we're going to divide it by 6. So we have 144 divided by 6. That's 24. Okay? Now B, 23 minus 56 divided by negative 8 plus negative 5. Whoo, buddy.
So we start with 56 divided by negative 8 because that's PEMDAS.
Yes. So we have this sandwich of stuff, but we have to start with division. These other guys are subtraction and addition. We got to start with the division. So the division has us doing negative 56 or minus, because we have the minus here. And we know that because we're combining two numbers that have different.
56 is not negative. You're subtracting 23
Yeah.
from 56.
Yes.
56 is not
You're keeping the we're keeping the subtraction here, right? So this is going straight down to this. But when we combine these here, we end up, no, this is positive here.
Yeah, but the negative sign.
But it will be, yeah. So then we have 23 minus, in parentheses, the negative 56 divided by 8 plus negative 5. So we have 23 minus negative 7, which is going to turn into plus negative 5. 23 plus 7 minus 5. So that is 25. Do you see how this can be complicated if we don't slow it down and keep track of what we're doing, giving yourself breadcrumbs and writing down your work, you can jack this up. All right. So negative 7 squared, Micah, is negative 7 times,
Negative 7.
which ends up being
49.
All right, now look at this. The negative sign was inside what was being squared. This, we're doing negative, the negative of 7 squared. 7 squared is 49. We have to put that negative sign. So this parentheses matters. Do you see how these are not the same?
Yeah.
They look the same.
I corrected you on this once.
Yeah, I'm sure you did.
And now you're like, oh, you have to do it. I'm Batman.
I don't think that I sound like Batman right now. I don't think that was a thing. So we can see examples of this here and here, right? We know that this guy is going to be negative, and this guy, well, that's tricky. Let's see this. So negative 8 times negative 8 times negative 8. What is that going to be, Micah?
8 times 8 is 64 times 8. Computing.
My question is it going to be positive or negative? Positive. Why? Because these first two are positive, and then we're multiplying by a negative. So we end up with a negative. Now, in likeness, this guy over here, we're going to end up with the same answer. And that's because the exponent is odd. Okay, I don't care. All right, so let's look at this guy. All right, this is where it gets fun, ladies and gentlemen. Well, actually, it gets more fun when you throw in variables into this, because you got to really keep track of what you're doing. So, Mike, are you ready? Negative 2 cubed times 7 minus, in brackets, negative 5.
Brackets?
This is a bracket here.
Right, what is a bracket?
It's like a building on of a parentheses. So you basically count it as a parentheses. But if there's a parentheses inside the bracket, you always do that first. Thank you for that burp. I'm sure Layne appreciates it.
Better, Layne.
We're going to take first negative. We're going to move that guy over here. So we're always going to do what's in the brackets. And then we're moving this guy straight over here. Okay. So we're going to deal with this center section first. Oh, and we're moving this guy over here. So in the first line, all we are doing is this. Okay. So negative 5 plus negative 1 is what, Micah?
Negative 5 plus negative 1 is negative 6.
Negative 6 squared. Okay. So now this is what we're working off of. So we're going to go ahead and deal with, we did the brackets first. Now we're going to, or the parentheses. Now we're going to do exponents. So negative 2 cubed is negative 2 times negative 2, which is positive 4 times negative 2. We get negative 8. We're leaving times 7. Then we have negative 6 squared equals positive 36 divided by negative 4. So now we have multiplication on one side, we have division on the other side, and we have subtraction in the middle. So essentially what we're going to be doing is we're going to be doing this. Okay, so negative 8 times 7 is 56. Then here's our minus. Then 36 divided by negative 4 is negative 9. So negative 56 minus negative 9, negative 56 plus positive 9 equals negative 47. So, holy cow. This is getting real quick. So this is all testing all the things we've learned so far. Just wait for fractions and variables to be thrown in there. And then that's a good old time. All right, so let's do this one, Micah. Let's do it.
Did I get a turn on that yet, Mom?
We're still doing the lesson, so you need to be quiet, okay?
Okay, so is that cubed?
Yes, it's cubed.
Okay.
So first, what are we going to do?
Minus 8 minus negative.
So hang on. 6 cubed divided by, so I'm rewriting this, plus, so what are we, minus 8 minus negative 3 squared. And what is that, Micah? That's negative 5 squared, which is positive 25. And I wrote 24, so that's super helpful. Okay. Times -2. So what are we going to do next?
Multiplication.
Nope.
Division.
I got a gold
Nope.
Pokemon card, Mama.
We did parentheses. What's the E?
Exponent.
Exponents. So -6 cubed.
6 times 6 is 36. 30 times 6 is 18. 180 plus 36 is 260.
I'm going to trust you. 36.
No,
No, 36 times 6. That sounds bananas. 6 times 6 is 36.
Look, I got a gold Pokemon card.
I'm recording the lesson for Layne. Okay. Can you be quiet for a couple more minutes? We're almost done.
260.
All right. So negative or positive? Negative, because we had a negative times a negative times a negative. These end up being positive, and then we have a negative times a positive, which is going to be a negative. So -216 divided by -12 plus 25 times -2. What are we going to do next, Micah? What's -216 divided by -12? What's -216 divided by -12?
Negative 216 divided by negative, that's 15. Well, 18.
So it's positive 18 because we've got a negative, two of the same. It's always going to be positive. Then we're going to do the other side of this plus sign. 25 times -2 is -50. So -50 or 18 plus -50 equals -32.
Yes.
PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction, moving from left to right within each of those subcategories. So, feel free, Layne, to pause if you need to and look at these problems. If you want to do a couple or you're like, I just don't get this, send me a note. You can work on whatever problems you're able to do in your workbook. And next time we are going to be working on rational numbers.